So so from the washer method practice problem, we did A, which was writing the equation, tangent line, order pair, slope, point slope form, area. We did top minus bottom. But we also practice working this out by hand. I do want to point something out here is that on the AP exam, if you see an area volume problem, that is a non-calculator problem, because sometimes they may insert a volume problem or area problem into a non-calculator portion of the FRQ. Typically, for volume, it's a little messier, so they typically don't ask you to work it all the way through. But for area, it's very possible they may ask you to work it out by hand, so get it all the way to the end. Because it's a little bit more manageable, it's not as messy, having to foil or expand all the way out. So this is manageable. It's just we do need to, it does require us to go through a use substitution with that pi x, and then remembering the rule of integration, and then involving the bounds to do the antiderivative. But you see for C and D, that's a fairly messy problem, and it's also hard to find the antiderivative with sine squared pi x. So typically ones that are too complicated or have difficulty finding the integration rules, they typically just ask you to set it up and not go past that. So for part C, rotating around a horizontal axis, there are no flat surfaces on this shader region, so there's no chance that this could ever be this method, right? Even if it is touching the graph. So we know no matter where the axis is, this is always going to be the washer method problem. So we do top minus bottom because we have a horizontal axis, and from the axis we extend to the two boundaries of our shader region, and then we do top minus bottom for both. The nice thing about top minus bottom is that we don't have to worry about rearranging the equation. The equations are usually set up for us, and then the bounds are in terms of x, so we go from 0 to 1/2. Okay, part D. Part D is also washer method, but here it's a vertical axis of revolution. So we know that with vertical axis, we got to take some additional time to rearrange the equations, right? We have to move things around, add, subtract, multiply, divide. We have to do whatever operations is required to move things around to get that x by itself. So for the y equals 8x cubed, I have to divide by 8 and then take the cube roots. Student from previous seventh period were asking, "Oh, can I clean this up?" You could say cube root of y over the cube root of 8, and you can make it down to cube root of y over 2. But this is fine. But if you want to continue cleaning up, you could. All these different variations. Okay. And then for y equals sine pi x, we have to get x by itself. I can't divide by sine, right? Sine is stuck inside that expression, but I can do inverse of sine. So I can do inverse of sine, move that sine over to the other side, divide by pi to get x by itself. So dividing by pi is same thing as multiplying by 1 over pi. It feels a little bit cleaner to push it out as a coefficient than dividing by pi, but it's up to you. And then once we identify every piece that we need, we can do right minus left for big radius and right minus left for small radius. And the bounds also have to be different, right? We can't go from 0 to 1/2. Those are x values. We want to go from 0 to 1 because those are our y values. Yeah.
So the cube root.
Mhm.
Can you just leave those?
Yeah, you can leave it like that. Yeah. You can do y over 8 to 1/3. You can do cube root of y over 8. There's a lot of different options. Yeah, I can do any of these. Any of these are fine. Yeah. Okay, any questions? All right, let's go to page 3. Okay, this is meant to be a calculator question here. And we have 2 curves here. We got the 4 to negative x. It's an exponential function, but it's a decay exponential problem, so that's why I'm decreasing. And then the sine curve here. All right, so R is that shaded region to the left before the intersection, and then S is the shaded region to the right. Okay, so find the area of S and then find the area of R. So we do need the calculator to find those intersections for us. So let's practice doing that. Also, your calculator will always be in radian mode. Okay, your calculator will never be in degree mode. Okay. I like to start with Zoom 6 just to see what I'm working with, but a lot of times I'm gonna have to zoom in because this is too small, right? It's that little region in the first quadrant. So I'm gonna do zoom box. If you want to zoom in even further, you're welcome to do that. Second trace, intersect, do it twice. Once for that first intersection. And then do it again for the second intersection. Now I'm going to move closer to the other intersection so that the calculator knows what I want to find. just one. Okay, so let's find the area. And we always want to try to explore top minus bottom first, especially if they're giving something to you in terms of a function. So, yeah, so it looks like both R and S can be found with just one area formula each, right? Top minus bottom for R, top minus bottom for S. But there is a change in the top function, right? The top function for R is the 4 to the negative x, but the top function for S is going to be the 1/4 plus sine pi x. Oh, you can. I think it's always good to get as much information as you need in case further problems requires you to do right minus left. I think it's good to have it. Yeah, I didn't do it, but I think it's good to just go ahead and write down the full load repair. I would say you don't have to worry about the parentheses if you are putting, or if you're calling y1, y2. That's the nice thing about y1, y2. If you call it within the function, it'll just protect that region. But if you want to enter everything in on the same screen, then make sure you either distribute that through or you put a parentheses so that the negative ends up distributed. So, but if you do y1 minus y2 or y2 minus y1, there's no need for parentheses. Oh no. And make sure that you are clear with the area formula. Area formula, there's no squared. I know we see so many problems involving squared, right? They're squared for this method, for washer method, for pretty much all the cross-section problems, but area is just top minus bottom, no square. Okay, look at part C. It's revolving around a line, so decide whether it's a top minus bottom, is it right minus left, is it this, is it washer method. And hopefully everyone is getting comfortable with their calculators, knowing how to find intersections, knowing how to call the integral notation. So, yeah. So here's the difference. The difference is that for this method, you gotta have a flat surface, first of all. Let's say this is a shaded region. And let's say this is y equals 1. Let's say the axis is also y equals 1. You see how there's no, it's like right up against that flat surface, there's no hole, there's no gap. That means it's only one radius needed, there's no second radius. Okay. Right. And then you just extend from, so all you do is big R for this method. That's washer, yeah. What about this side? What if I had this graph? Axis here. Sure, right, it's touching, but there's a gap, so I know I gotta draw two radius. Right, careful with that -1, right? Minus -1, minus -1, it's gonna turn to a positive. And with Washburn Disk method, we do square our radius. Make sure that you're squaring your radius separately. That you don't do big R minus little r and then put a big exponent around it. Okay, that's not good enough. We got to square the radius separately. And this is where I really like to use my y1 and y2. Because if I can go back and call this y1 and call this y2, then I can just go to my home screen and do F or do math 9 F an integral, and then I can just call my y1 y2 without all these extra parentheses and brackets in the way. So feels a little bit cleaner, but you get to your y1 and y2 by doing alpha trace, right? Alpha trace will give you the menu of all the y1 through y8. All right, any questions with C? Okay, so we did area, we did volume, rotated around an axis, and now part C is volume by cross section. So read the description. The problem will always tell you how to draw your base length. It's a vertical, it's a horizontal, but the problem is always gonna use it in words like parallel or perpendicular to the X or the Y axis. So just So for part D, parallel to the y-axis, that's vertical, so, we can just, connect, the two boundaries in region R. That will be your base length. And once you have your base length, then you can insert it into the appropriate area formula. Isosceles right triangle with leg on base is 1/2 base squared. And if you use the bounds that you've already gathered from part A, push that area into a volume formula by including the integral. That's it. We're good with page 3. Go ahead and flip over to page 4. I'm just going to try to work through page 4 and then we'll be done. As for number 2, I include the y-axis as frame of reference, but it's not a boundary that we use. So it's just the x equals -1, the natural log graph, and the x-axis. Vertical axis of revolution, it's right up against that boundary of the shader region, which is a flat surface, so we know it's gonna be this method. We know it's gonna be a horizontal radius, we know it's gonna be right minus left, we know we have to spend time to rewrite our equations, right? So. And we have to find the y-intercept for our bounds, right? Our bounds is from 0 to whatever this y value is. Now, you're not gonna be able to use your calculator, graphing wise to find that intersection, right? Because it's just a y-intercept, so. And also, we can't graph a vertical line on your calculator. But what you can do is, your y-intercept has has an x value of 0. So if your x value is 0, you just simply insert 0 in for x. That will get you your decimal value at that point. Okay, rewriting the equation, y equals natural log of 4 minus x is perfect for top minus bottom, but it's not quite set up for right minus left, so we have to solve for x. Raise both sides with e as the base. Clean this up here, e to the y stays, but the right side needs to be just 4 minus x, it's the natural log go away. Solve for x equals 4 minus e to the y, so that is the curve on the right. The left side is -1, so we do 4 minus e to the -1 minus the -1, combine like terms. That's 5 minus e to the y. All we need is one radius, there's no gap. The big radius squared from 0 to 1.61. Okay, part B, rotating around a vertical axis revolution. Now that this axis is on the other side of the shader region, there's no flat surface here, so we know it's going to be a washer method, still right minus left. But the nice thing is you've already found most of the information that you need from part A, so a lot of information from part A can just be reused. Same balance. Yeah, and also something I think I brought this up before, but that I think sometimes we look at the axis, especially if it's like far away, we feel like, oh, I gotta involve that in my bounds. The axis has no say as to what the bounds is. The bounds is just for the shaded region alone. So the bounds would be the same if it was area, if it was This method, washer method, cross section is just the shaded region. Okay. So don't let the axis, the location axis throw you off. It's not going to impact the way you find the bounds at all. Intersection here.
Wait, I'm gonna- Because like each of them red.
Oh, you are talking about this?
Yeah, like that's how it's trying to.
Oh,
We're doing it super.
oh, yeah, I guess I think it's.
Oh, okay, so just put it back.
Yeah.
And slide.
Yeah, so the outside parentheses is built in. We can't do anything outside of that,
Okay.
so.
Okay. For Mark, okay. I just think it's like-
This curve is not before my. This curve is actually y minus a to the y. Because, I think, let's see. No, you're right. What's the issue? This is. 4 minus. Minus e.
Oh, that's easy. Because it should be.
No, that's right. I think this is right.
No, that's.
Once you get this 4 minus 1.2.
Oh, you put the Y. But she put the Y on. 4.6 is like.
Oh, okay. Yeah, the y value is for the bounds, but this equation is x equals -1, so I gotta do 4, which is the right endpoint, the left endpoint is at -1, so it's 4 minus the -1.
Because it's 1.6.
Sorry, the 1.61 is used, but those are the bounds for my shaded region. It's not the actual equation. Okay, for part C, parallel to the x-axis, a rectangle whose height is 4. So, you find the base first, and the height is given to you. The area formula for rectangle is base times height. So I take my base, I take my height, multiply them together. That is my area formula. And then just have to insert my valve from 0 to 1.6. So for next Wednesday, what I plan to do is continue with the packets. I think there may be more problems than what we have time for. So I was going to kind of highlight a couple of these problems here real quick. And I'll go back to this if you need it, but it's also in your packet. I think we kind of did this problem. We did parts of page 5. So if we have time on Wednesday, we'll come back to it. Page 6, we'll come back to it if we have time, but I really want to focus on pages 7 through 10. So we'll do these FRQs 7, 8, 9, and 10. These are just FRQs that I've gathered from previous AP exams. So you kind of see the different variations. And then pages 11 through 13, I'm going to save this for the morning review on Thursday, but you're more than welcome to work through this. I think this is going to be kind of like the length of your test. It's about 3 pages. So 11, 12, 13 is a good indication as to what to expect in terms of the length of your test. But with a long layoff, I want to make sure that you guys don't forget these things. So if you feel like you want to do some of this over break, you're welcome to, but just to give you a plan, we'll do about 4 FRQs on Wednesday, and then Thursday morning, I'll do pages 11 through 13. All right, any questions? All right, come and get your phones.
First you start to.
Yeah.
You cube it.
That's right. Yeah, you can split it up
The
into
bottom and square the first.
Yeah,
Next one.
that's the easier way, because you break the number down first, and then it's easier for you to break it down. Yeah, thank you.
Like looking straight at it. I wanted to jump on those lines. I think they're gonna get it.